Let's be honest, when you hear words like firewall or IP tables, your eyes might glaze over a bit. It sounds complicated, right? Well, what if I told you it's all just like a bouncer at a nightclub? We're about to pull back the curtain on this stuff, and I promise by the end of this, it's all gonna click.
So here's our game plan. First, we'll meet our digital security guard. Then, we'll figure out what addresses and doors they're actually watching. After that, we're going to open up their official rulebook, IP tables, and even write a rule ourselves. And to wrap it all up, we'll cover some pro tips so you don't make common mistakes before putting that whole puzzle together.
Okay, so let's start at the very beginning. What is a firewall, really? If we strip away all the technical jargon, the idea behind it is incredibly simple.
I want you to picture a security guard standing at the front door of an exclusive club. They don't just let anybody walk in, right? They're checking two very specific things. First, who are you? That's your IP address. And second, which door are you trying to use? That's the port. Based on their list, they make a simple choice. You're in, that's an accept, or you're not, that's a block. That's a firewall in a nutshell.
Now, this security guard, they can work one of two ways. The first is a blacklist. That's like having a list of known troublemakers. If your name is on the list, you're out. But everyone else gets in. The other way, which is way more secure, is a whitelist. This is like a VIP party. If your name's not on the guest list, you are not coming in. Period. Everything is blocked by default. And for security, that's almost always the way you want to go. So our security guard is checking two things: your ID, the IP address, and the door you're trying to use, the port. We get what an IP address is, but what exactly is a port? Let's dig into these building blocks. The best way to think about it is this. If your computer is a big house, then ports are all the different doors. You've got your front door, your back door, your garage door, and you wouldn't use the garage door to get to the living room, right? Software works the same way. Different applications are designed to use specific, numbered doors to send and receive information. And a firewall rule is really just an instruction about which of these doors should be locked and which should be wide open. And what's really interesting is that a lot of these doors are standardized. When you browse the web, your computer is usually knocking on door number 80 or 443. If you're trying to securely log into a server, that's almost always port 22. This makes things work smoothly, of course, but it also gives attackers a roadmap. They know exactly which doorknobs to start rattling first. Now, here's a super important point, so let's be really clear. When we're talking about firewalls and ports, we are not talking about the physical plugs on your computer, like USB or HDMI ports. Those are hardware ports. We are talking about thousands of virtual, numbered pathways called software ports. Our digital security guard couldn't care less about your USB cable. They only watch these software doors.
Okay, so we've got our guard, and we know what they're looking for: IPs and ports. But how do we actually give the guard their instructions? Well, on most Linux systems, the answer is a really powerful command line tool called iptables.
Think of IP tables as the program you use to write the official rulebook for your security guard. Every single decision that firewall makes, every person it lets in, every connection it blocks, is based on a rule written in this book. It's the command center. And this rulebook is nicely organized into chapters, or what are officially called chains. The input chain has all the rules for traffic coming into your computer. The output chain is for all the traffic leaving your computer. And then there's a forward chain, which is for traffic that's just passing through, like when your computer is acting as a router for another device. All right, time for the fun part. We're going to look at a real-life iptables command. Now, I know it might look like a foreign language at first, but I promise you, in about 60 seconds, this is all going to make perfect sense. Okay, there it is. Let it sink in for a second. It looks pretty intimidating, doesn't it? But all it is a single sentence telling our security guard a very specific instruction. So let's just translate it piece by piece. So we start with iptables-a input. That just means, hey, iptables, I want to append or add a new rule to the input chapter of the rulebook. Simple enough. Next, -p TCP says this rule only cares about the TCP protocol. And then -s 10.0.0.105 tells the guard this rule is for traffic coming from the source IP address 10.0.0.105. See? We're building a sentence. And the second half is just as logical. The -d port 22 part specifies that the traffic isn't just coming from that IP, it's also trying to get to destination port 22. That's our SSH door. And finally, the -j reject part. This is the action. The -J stands for jump, like jump to a conclusion. And that conclusion is to reject it. And that's it. We wrote a complete instruction. Okay, so now you know how to write a basic rule. But knowing the grammar is one thing. Actually using it effectively, and more importantly, not locking yourself out of your own system, well, that requires a few pro tips. So this brings up a really important question. What happens if you have two different rules that could both apply to the same connection? Let's say one rule allows it, but another one blocks it. Which instruction does the guard follow? Which one wins? The answer is simple and absolute. The first one wins. iptables reads that rulebook from the first page to the last, top to bottom. The very instant it finds a rule that matches the traffic it's looking at, it follows that rule's instruction and stops reading. It does not keep looking for a better match. This means the order of your rules is everything. Here's another pro tip. You need to know the difference between drop and reject. Reject is like slamming the door in someone's face and yelling, "Go away!" They know you're home, and they know you've blocked them. Drop, on the other hand, is like turning off all the lights and hiding. The request arrives, and you just silently ignore it. The sender gets nothing back and probably assumes the system isn't even online. For security from the outside world, drop is way stealthier. And you want one of the easiest, most effective security wins you can get? Here it is. Automated bots are constantly scanning the entire internet looking for open SSH doors on the default port 22. By simply changing your SSH service to listen on a different port, like 2222, you become instantly invisible to 99% of those automated attacks. It's a simple trick, but it works. All right, we have covered a lot of ground here, from the big picture ideas all the way down to the details of a single command. So let's zoom back out and put it all together one last time. When you boil it all down, the whole process is just these 4 simple steps. 1. A little packet of data arrives at your computer. 2. The firewall opens its rulebook to page 1 and starts reading down the list. 3. It finds the very first rule that matches that packet's details. And 4. It immediately takes whatever action that rule says to take, accept, drop, or reject. That's the whole dance right there.
So if you forget everything else, just remember these analogies. The firewall is your security guard, the ports are the doors into your system, the IP address is the person knocking on the door, and iptables, well, that's just the rulebook that tells the guard what to do. So there you have it. We've taken a pretty complex topic and turned it into a simple story about a guard, some doors, and a rulebook. You now have the fundamental concepts you need to understand this powerful security tool. So the only real question left is, now that you have the rulebook, what's the first rule you're going to write?